Tolerance or specification setting for shaft and bearing, finding the appropriate clearances or whether it's going to meet that certain clearances, and that's what you're going to show in this video. And there is not just shaft and bearing, there are numerous examples like nuts and bolts. There is some, always there is part that fit one inside the other. So the common question is there enough clearance? Is it too loose or too tight or things like that? So assuming that we have this bearing diameter, for example 30 inches, and then the shaft diameter is 29.6 inches. So let's say you got a shaft like this, and then that one is 29.6 inches, for example, and then it's going to fit into a bearing which has a diameter, for example, of inside diameter of 30 inches, for example, and the standard deviation is given, the sigma is given. So how do you calculate that? First you have to find out the total variances. Now remember, variance only add, you don't subtract it. So even though we're going to find the clearance by subtracting, so basically the clearance between the bearing and shaft, in this case the mean clearance we want is this. So that's the mean clearance. Now it will have interference if it's less than 0. So that's the mean clearance we want. We need to find out the sigma for these total components. To do that, first we have to calculate the variance, which is the square of the sigma. So this times this, and then copy that down, and then the total here, sum of these two components. Remember, it doesn't subtract, it always variance and variations get always added, and then a square root of this variance will give us the standard deviation. So that's that. Now what you're trying to do here is basically, if this clearance is less than 0, so if you know when we subtract this bearing dimension, so if this, say for example, this is x1, this is x2, so if x1 minus x2 is less than 0, then we have a problem, we have an interference. So finding the probability of x less than basically 0. So what we are trying to find out is x less than 0. If it's less than 0, then we have a issue. So in this case will not it will not fit. So it's very simple function in Excel we can use called norm dist that will give me the probability. So let me show you first what we are trying to find out. So in a normal distribution, assuming that all these parts, bearing and shaft you are producing, the clearance will be normally distributed. And then what you're trying to find out, so that's the mean clearance, which is 0.4, and then let's say this is 0, and then so anything less than that is not going to fit. So all we are going to do is basically find the probability less than 0. So here we can write norm dist, very simple, probability of less than 0, mean value of 0.4, standard deviation for the component, the assemble, the clearance is that, and then comma cumulative. This will give us the probability for the parts that will fit. So if we make this bearing and shaft with this specification here with this standard deviation and that, then about 21% will not fit. So if we make a, say 100 of these, 21 of them will have interference, clearance less than 0. And of course you can find out clearance more than some number if you're interested in, let's say you want to find out how many of them will be too loose, let's say for example 0.8 for example. So you can calculate that as well. So probability of shaft and bearing that will have too loose, which is at 0.8 for example, more than 0.8. So simply we can do again norm dist, and then 0.8 that we're trying to find out. Same mean value for the clearance, the standard deviation. Oops, I think I should select this guy for the mean. And then this is for the standard deviation. And then cumulative. So that will give me all the area up to this point from the left. So what I want is basically 1 minus of that. So that could be 1 minus of this. So that kind of came same, but if you change that 0.8 to, let's say, 0.1, for example, like this, so then you will see, so if you want to calculate this probability, let's say that's 1.0, to clear high clearance. So anything over that is 0.115. So you make 100 of them, about 11 and a half of them will not fit, well, will be too loose. And then here up to 0.8, I think we found 0.215. So basically, if you make 100 of them, 21 of them will be too loose. So you can, and how many of them will be in the appropriate dimension, you can simply, that's the middle area, you can calculate easily.